Assalamualaikum warahmatullahi wabarakatuh. We are from Group D conducting assignment 3 about deep learning model for image detection using convolutional neural network.
Our objective in this project is to accurately categorize image into predefined classes and evaluate the model's performance on unseen test data. Next, to evaluate the accuracy of image detection and visualize bounding boxes around the objects. And lastly, to optimize the model for effective generalization, ensuring reliability on new unseen data. So moving on to dataset, our dataset is sourced from the COCO dataset, which is widely used for object detection tasks. So for this project, for this assignment, an image of an elephant in a natural setting was chosen. So for this image, these 3 pre-processing steps are included, which are resizing images to 300 times 300 dimension pixels for uniformity. Next, we convert it into grayscale to emphasize edge detection and contour generation. And lastly, we apply adaptive thresholding, specifically using Otsu's method to achieve optimal segmentation. So last but not least, for our model creation, we use CNN, where these 3 features are used, which is feature extraction, where several convolutional layers are equipped with ReLU activation functions, and max pooling layers to reduce spatial dimensions while retaining essential features at the same time. So next is classification head, where a fully connected layer with a softmax activation function for multi-class classification. And lastly, bounding box regression head, where a linear output layer is specifically designed to predict bounding box coordinates.
Explaining about the experimental setup. So for the training part, we started with the training phase, which focused on teaching the model to classify objects and predict their bounding boxes. So to make the training effective, we set the learning rate to 0.001. So this ensures a good balance between speed, stability during the training process. So we used a batch of size 32, which made the training more efficient and stable. And the model was trained for 10 epochs, meaning it went through the dataset 10 times to learn patterns and improve accuracy without overfitting. So after training, we tested the model using unseen images, and during this phase, the trained model predicted the object classes and bounding box coordinates. We visualized these results to check the model's accuracy and ensure that the detected objects were aligned correctly with the target. So for example, in one of our results, the model successfully detected an elephant in an image, highlighting it using the contour-based methods. And finally, we evaluated the model's performance. This included analyzing the visualizations and calculating the accuracy metrics. The bounding boxes were actually checked to ensure they accurately located the detected objects without overlapping relevant areas. And after completing 10 epochs, we validated the model on new images and visualized the bounding boxes. And we also plotted the training and validation metrics such as accuracy and loss to assess the model's overall performance. So through this setup, we integrated classical image pre-processing techniques with deep learning to create a robust object detection pipeline. And this project sets the stage for more advanced applications such as real-time detection system. Thank you.
Bismillahirrahmanirrahim. So now I will continue with the code implementation for this assignment. So basically our project focus on object detection and analysis using CNN, and the process begins with the dataset preparation, and where an image is resized and pre-processed using grayscale conversion, the detection, and also we extract the contours for object detection. So this is what we look and display image dataset. So basically the dataset we get from the COCO website. This is the publicly available dataset, and there are thousands of images in the dataset, but we only focus on one raw image so that it is easy for the implementation in this code. So we will go through one by one, and as you guys can see, the object detection, this is the line of the code, where from the raw image, the contours were filtered based on their size to eliminate noise, and bounding boxes were drawn around the detected objects, and a mask was applied to highlight the detected regions. And for the model creation, as you guys can see here, where CNN were applied in this code to build the separate outputs for classification and bounding box regression. So the classification is to predict the object class. Meanwhile, for the bounding box regression is to define object localization by predicting bounding box coordinates. So next, for the training and testing dataset, we generated a synthetic dataset of 1,000 images. But as I mentioned just now, for this assignment, we just focus on one image, and the generated synthetic dataset of image is with random labels and bounding boxes. So the model was trained for number of epochs using the optimizer, and it will track both training and validation accuracy and loss. So for the next part, evaluation part. So evaluation part, we do the prediction for the unseen image. The model was tested on unseen data, and it predicted the bounding boxes which were visualized over the images. And we also plotted training and validation methods to evaluate the model's performance. So here is the results of this code. This is the original image we download from the dataset, and this is what CNN do in our code. We will resize the image, grayscale the image, and implement the edges of the object, and filter detected objects. This is the contours that I mentioned just now. The bounding boxes, it will detect particular or significant object within the regions of the images, and this is the object masking. Even though in our code maybe it is not too accurate, the accuracy is not too high, but at least we succeed to detect some particular or some significant object within the regions of the images. So this is the number of epoch to test the accuracy. Here 5 epochs were conducted, and this indicates that the training dataset was divided into number of batches, and all batches were processed during each epoch. For example, here for each epoch, the total training time is displayed. For example, epoch 1, it took 146 seconds, while epoch 2, it take 196 seconds. And this measures the percentage of correctly classified samples during training. So this is the implementation of our code in this assignment.
First, to wrap up, our project successfully combined traditional image processing techniques with deep learning to create an efficient object detection system. Let's summarize this in 4 key aspects. Okay, the first one is object detection. We improve contour-based object detection using edge detection, adaptive thresholding, and bounding box filtering. We leverage this traditional method, all these 3 methods, to enhance object detection. This technique works comprehensively to extract relevant image features, isolate object of interest, and minimize noise. The result was a reliable detection system that efficiently identified and segmented objects across various scenarios. Okay. The second one is evaluation. The system performance was tested on unseen image, where it demonstrated the ability to accurately detect and localize objects. This evaluation highlighted the robustness and adaptability of the system, confirming its potential for practical application in real-world environment. Okay, for the third one is model creation. We developed a convolutional neural network designed to perform dual tasks, which is object classification and object localization. By incorporating separate output for this function, the model becomes versatile and become capable of simultaneously identifying object types and predicting bounding box with precision. Okay, and the last but not least, the optimization. We conducted experiment to fine-tune learning rates, batch size, and contour area filtering threshold. This optimization played a critical role in improving both the detection accuracy and the overall efficiency of the system. The process allowed us to refine the performance while maintaining computational feasibility. Okay. In conclusion, the project highlights the benefit of integrating traditional image processing with deep learning. This has been done to achieve efficient object detection. While the system performs well, it also opens avenues for future enhancement, such as incorporating larger and more diverse dataset, exploring transfer learning, or employing more advanced architecture. Okay, I think that's all from me, and that's all from our groups. Thank you for your attention, and Assalamualaikum warahmatullahi wabarakatuh.